In one of my recent videos, I demonstrated how to create a mini eGPU using readily available off-the-shelf parts. However, that build featured a PCIe-powered graphics card, which is not the case for most modern gaming GPUs. While some capable cards, like the Ada SFF A4000, still run on PCIe power alone, most of the gaming GPUs now require separate PCIe power inputs directly into the card. With the recent rise in Oculink-based external PCIe solutions, I thought it would be a fitting sequel to showcase an Oculink-based mini eGPU using a standard low-profile graphics card, making it a more practical solution for a wider range of users. For those unfamiliar with, Oculink is a PCIe-based external connectivity protocol similar to Thunderbolt, allowing PCIe devices like GPUs or capture cards to connect externally to a computer. Despite offering higher bandwidth than Thunderbolt, Oculink hasn't seen widespread adoption historically over the years. However, due to its cheaper implementation costs compared to Thunderbolt, largely due to licensing structures, its adoption has been steadily increasing in recent years, which is great news for the DIY and the enthusiast community. The star of today's build is this PCIe-to-Oculink adapter, which is readily available online. I picked mine up from AliExpress for about $40. The kit also comes with an NVMe-to-Oculink adapter, allowing us to add Oculink support to a system that doesn't have dedicated Oculink port. For power, I'm using a PICO PSU that I purchased from Amazon as our main power supply. To extract the necessary 12V PCIe power from the PSU, we will use SATA and Molex adapters, which will be then merged using a cable to provide the PCIe power required for our GPU. Please note that I decided to use Molex mergers as it's a bit more secure than SATA. If your PSU has dedicated PCIe output, you should use that instead. This setup should work well for the lower-end GPUs with a lower TDP. But if you are planning to use a high-wattage GPU, be extremely cautious with DIY power connections. SATA and Molex input pins have strict current limitations, so keep that in mind when setting up your system. For long-term stability, safety, and reliability, I'd recommend using a PSU like this one, which features a dedicated 12V output line with higher current support. Alternatively, you could opt for a smaller DC to ATX converter, such as the RGIG or the HDPlex models. I didn't have those available when filming this video, so I used these converters instead. That said, I always advise avoiding splitters, mergers, and converters whenever possible when building PCs and peripherals. For this specific Oculink PCIe board, there appears to be a dedicated GPU power output of up to 180V, taking its juice from the ATX 24-pin inputs, which could be another way to power the GPUs. However, I couldn't find any official documentation to confirm this. The bottom line is, always remember that PCIe power connections have their limits, and exceeding them can pose serious fire hazards. If you have followed the stories about 4090 power connector meltdowns, or more recently the 5090 issues, you already know how critical power management is for PCIe connections. Finally, the GPU we are using today is this Gigabyte RTX 4060 low profile. Compared to what most commercially available mini eGPU enclosures offer, this is a significant upgrade. Now let's start building. First, we'll assemble the SATA Molex PCIe contraption and prepare the PSU for connection. We'll attach the vertical support to the base, then connect the PSU directly to the board's 24-pin ATX power connector. Next, we install the GPU onto the board and then connect the prepared PCIe port to the GPU. Then, we do some basic cable management. The PICO PSU we're using features a 12V DC barrel input, which I have installed through a hole I drilled in the transparent case cover that comes with the Oculink adapter. We'll connect the DC port to the PSU inputs and close up the case cover to complete this quick and easy installation. To add some stability, I also installed rubber feet to reduce vibrations. Additionally, I recently designed a much sleeker case for this setup, taking this eGPU to another level in terms of aesthetics and ease of use. One of the best parts of this build is its affordability, ease of assembly, and upgradability. You can swap in another similarly sized GPU or even other PCIe peripherals like NVMe expansion cards. When compared to common desk accessories like mice or gaming controllers, the compact nature of this setup is remarkable, considering the power it offers. For testing, I used my Latte Panda Sigma board, connecting the included NVMe-to-Oculink adapter to one of its NVMe slots. Many modern laptops and mini PCs now come with built-in Oculink ports, and if yours doesn't, it's not difficult to convert a Thunderbolt port to Oculink. I'll be covering that in a future video. The setup process for this is identical to previous eGPU setup I showcased, which I'll link below. One key point to note is that Oculink, unlike Thunderbolt, is not always hot swappable. However, When using a GPU, even Thunderbolt isn't truly hot swappable, so the process remains almost identical in both cases. If Oculink isn't your preference, you can opt for a Thunderbolt-based adapter card instead. However, be aware that Thunderbolt adapters tend to be more expensive and larger in size. Aside from that, build process remains the same. So if you're looking for an all-in-one mini eGPU solution that doesn't break the bank, this DIY approach is definitely worth considering. For those involved in workstation tasks or machine learning, you could swap out the RTX 4060 for an SFF Ada low-profile card, which has similar footprint and should fit in the same case. Additionally, a company called Nardware has designed low-profile heatsinks for these cards, making the setup even more compact if needed. If you enjoy unique and efficient DIY builds for everyday peripherals and gadgets, please consider subscribing to my channel. I have several exciting projects lined up, which I'll be working on as time permits in the upcoming weeks. As always, thanks for watching, and I hope to see you in the next one. Cheers.